Welcome to the Chapter 6, Lesson 4 video on isosceles triangles. By the end of this lesson, we will be able to figure out what makes isosceles triangles unique. Let's take a closer look at the isosceles triangles. We touched on this very briefly in a previous lesson, in a previous chapter. This top is called the vertex angle, and yes, all 3 points here are technically vertices. We are specific to this one that is at the top. When I say top, I mean it's in between the 2 legs. So the angle that is in between the 2 legs, the angle that is opposite the base, is called the vertex angle. Then we have the 2 legs. The legs are those sides that are the same length. The base is the side that is a different length. And then the 2 angles that are on the base are called base angles. A theorem with the isosceles triangle is that if 2 sides of a triangle are congruent, which is by definition isosceles triangle, then the angles opposite those sides are congruent. So using that and applying it to the picture from the last second there, we would say that since these legs are congruent, then the angles that are opposite those legs are also congruent. So that means these base angles actually end up being congruent also. So an isosceles triangle uses these 2 congruent legs to state that their base angles are also congruent. And this was very briefly brought up in the last lesson, that when you are dealing with an isosceles triangle, the median, altitude, perpendicular bisector, and the angle bisector all lie on the same line. When we're dealing with isosceles triangles from the vertex, that vertex angle up top, the median, altitude, perpendicular bisector, and the angle bisector are all the same segment. Remember, by definition, the median goes from the vertex to the midpoint of the opposite side. So these 2 sides are congruent. Then we talked about the altitude and the perpendicular bisector. The altitude goes from the vertex to create a perpendicular angle relationship with that opposite side. So this segment also ends up being the altitude. The perpendicular bisector starts from the midpoint, so it starts down here and creates that 90 degrees. Well, it just so happens that starting down here at the midpoint, creating this 90 degrees, it still ends up going up to the vertex. So it's that same segment. And then the angle bisector, the segment that would split this vertex angle in half, is the exact same one that's splitting the triangle in half with that midpoint. So the altitude, median, perpendicular bisector, and angle bisector are all the same line when you are looking at an isosceles triangle. And again, this is from the fact that this top angle here is the vertex angle, and these are the congruent legs. These I marked congruent simply because of the median, okay, of creating that midpoint there and splitting that bottom side in half. So now let's use this information to find missing pieces. In this triangle, I purposely did not label the vertices because I wanted to focus on the fact that it says that triangle CAR is isosceles with vertex angle A. So that means that vertex angle A is the one that's in between the 2 congruent sides. Now, it looks to me, just based on the way that this triangle is set up, that I would prefer to set up as A being in the middle there at the top. And then since it does say CAR, I'm just going to go clockwise with this naming and just make it triangle CAR here. And then the vertex angle is A. So since it is isosceles and A is the vertex angle, I can label those congruent, and I can also label those angles congruent, which is helpful because it says that the measure of angle R is 53 degrees. So I'm just going to continue to label with the information that is given. I am supposed to find the measure of angle C. Well, those 2 angles are congruent. So the measure of angle C will also equal 53 degrees. And then the measure of angle A, we're going to have to use the triangle angle sum theorem. So I'm going to take 180 and I'm going to subtract the 2 53 degree angles to get 74 degrees. So the measure of angle A equals 74 degrees. This triangle is already labeled for us. All the congruencies are marked. The only information that's not labeled is that the measure of angle F is 124 degrees, so I am going to go ahead and put that in there. We need to find the 2 missing angle measures, and then we're supposed to find the value of, or the length of DF, so that's going to require finding the value of X in there first. But before doing that, I'm going to go ahead and find the angles. Because angle D and E are congruent, I'm going to take the 180 in the triangle angle sum theorem, subtract the 124, and then that measure needs to be divided in between two angles equally. So the measure of angle D is equal to the measure of angle E, which equals 78 degrees, and we've taken care of those two angle measures. In order to find the side length, I need to use the fact that these two sides are actually congruent to solve for x. So I just did that really quickly. I subtracted 2x from this side. I added 3 to this side. So x equals 5. So then 2 times 5 plus 2 is 12. So df equals 12. And these are my answers to this problem. Okay, this is going to be the last one that I will walk through step by step with you. It does look a little complicated because we've got a couple of triangles going on in here. So the very first thing I think that's easiest to find is the value for x because of these congruency marks here. So this congruent tick mark is marked with a 20, so then this one over here is also 20. So x very quickly equals 20 degrees, or not degrees, just 20. Then what I have here is I've got two congruent angles over here, and the end goal is y. So let's see if we can get closer to our y measure here. 42 down there, so that's going to mean that it's 42 also up here. But unfortunately, I don't know what this whole angle measures, so I can't just take a number and subtract 42. I need more information, and so it's actually going to require that I find this angle down here that I don't know. So I'm going to take 180 and I'm going to subtract 84, and that 84 is coming from these two 42s. So I'm subtracting 84 to get 96, and that 96 is now this angle measure down here. And since that is 96, now I can jump into this triangle using the fact that this is a linear pair. And so I'm going to take 180 and subtract 96, and hopefully we see the relationship between these two differences. It's just going to be 84. So this is 84 on this side, which because of congruency marks, this is also 84. And now finally, I can jump back up to y there by taking 180 and subtracting the 168 from the two 84s, which is 12. So y equals 12 degrees. So let me just talk where this 168 came from. The 168 is the 84 plus the 84. I'm subtracting it from 180 because there were 180 degrees in a triangle. The 84 came from the fact that this line, this linear pair here, had a 96. The 96 came from 180 minus 84. And that way we use the triangle angle sum theorem to find this angle here. So at the end of the day, x equals 20 and y equals 12 degrees. I do want you to go ahead and try problems D and E on your own, please. Pause the video, work through those, and then you can continue on with the video and check your answer. The only thing I'll say about problem D is that in this problem it says triangle MPY, but it has no mention of which is the vertex angle or not. So you can label this triangle however you want, but you just may have to realize that it might not end up matching the way that it looks. So you may put the like MPY, but then maybe M ends up being the vertex angle, which it doesn't look like it should be based on this, the way that it's drawn for you. So you just have to take that into consideration as you start these problems, and especially the triangles that aren't labeled for you. Okay, so go ahead and give D and E a try. Hope you guys were able to work through those problems without many issues. If you do have any questions, please be sure to reach out to your teacher. So this concludes the lesson 4 on isosceles triangles. So what makes isosceles triangles unique is that isosceles triangles have 2 congruent legs and 2 congruent bases. And we could even go as far as adding in the fact that the median, the altitude, perpendicular bisector, and angle bisectors are all the same segments.